So in this lecture I am going to do questions numericals of relative velocity. So today I will take some numericals on the relative velocity of river related problems. You see the question number 38. It is given in your book on the page number 197. It is given. You see the question number 38. Water of a river is flowing with a speed of 5 km per hour. Means river is flowing with this speed 5 km per hour. And swimmer can swim with what speed? 10 km per hour in still water. Still water means when the water is not flowing. You have to find in what direction the swimmer starts swimming in the river so as to cross the river by least possible path. Means you have to find in what direction should the swimmer swim so that he cross the river in the least possible path. See here, this is the river, and suppose the river is flowing in this direction. It is clear. Now if you see here, if the swimmer is swimming in this side, what is the least possible path? Least possible path is this. This is the least possible path. If the swimmer is swimming, if he keeps his strokes in this direction, what will happen? Because of the flow of the river current, what will happen? His direction will become this. This will become this. Means instead of going through this direction, due to the influence of the river current, what will happen? He will be pushed in this direction, and now he will move in this direction. So he has to travel in this direction. So how he can travel in this direction? So you can see here. Now if he swims in this direction at an angle theta from the shortest path, then what will happen? Because of the flow of the river current, he will come across this direction. So see here, this is the direction of Vs. This is the direction of VR. Under the influence of Vs and VR, what will happen? His ultimate direction will become along this, which is the shortest path. So you have to find this angle. At what angle he should swim? So you find out with respect to theta, VR is what? Perpendicular. Vs is what? It is hypotenuse because it is in front of theta. So you find out sine theta. Sine theta will be equal to VR upon Vs. VR is given how much? 5. Vs is given 10. Means 1 by 2. So for which angle sine is 1 by 2? Sine 30 degree equals to 1 by 2. So what will be theta? Theta will be 30 degree. So what should be his direction of swimming so that he can adopt shortest path? It will be theta plus 90. 90 plus theta from the direction of flow of river. Flow of river is this. It is clear. From this direction, he should keep his angle how much? 120 degree. So at an angle of 120 degree from direction of river. It's clear. Now the second part you can see here. In second part, in least possible time. So you see here, if we assume that the width of the river is d, it is clear. What will be the component of Vs in this direction? Component of Vs is in this direction. You can see here, this is the actual direction of swimmer. What will be the component of this Vs along this direction? So it will be Vs cos theta. Vs cos theta. So what will be the time? So you evaluate the time. Time equals to distance upon speed, d upon Vs cos theta. Vs cos theta. But you have to keep the time minimum. So for minimum time, as you know that d cannot change, this is the width Vs, it is having a fixed value 10 km per hour. So cos theta should have the maximum value, because when cos theta will be maximum, time will be minimum. What is the maximum value of cos theta? It is equal to 1. Means theta will equals to 0 degree. As we know that cos 0 degree equals to 1. Theta equals to 0 degree, it means this angle is now 0. This angle is 0. It means what will happen? He should swim in what direction? In this direction. He should swim in what direction? You can see here, he should swim in this direction. If he is swimming in this direction, what will happen? Swimming in this direction, then he will cross the river in the least time. So see here, what will be the answer? Here I am writing what is the answer. Answer will be, to cross the river in the least possible time, swimmers should keep his stroke normal to the flow of river. Swimmer should keep his stroke normal to the flow of river. Means in this direction. It is clear? This means what will be the angle from the direction of flow of current? It will be 90 degree. This angle will be 90 degree. So you remember this, that if the swimmer wants to cross the river in the shortest possible, in the least time, then he should keep his stroke normal to the flow of river. If river is flowing in this direction, then he should swim in this direction. Then what will happen? He will take the shortest time in crossing. Now see the next question. This is the problem number 32, and perhaps this problem is given in your book in solved. So in solved problem it is given, but here I am explaining. It's clear. You can see here. This. A boat having speed 5 km per hour in still water. Means what is the speed of the boat? Speed of the boat is 5 km per hour in still water. In still water, crosses a river of 1 km in 15 minutes via the shortest possible path. So you know that what is the shortest possible path? It is this. It's clear. Via the shortest possible path, this is the 1 km, and how much is the time taken to cross? 15 minutes. Means what is the speed of the boat in this direction? Speed of the boat in this direction. It's clear. So see here. Here speed of boat will be what? You can find very simply. What is the distance to be covered? It is 1 km. In how much time it travels this distance? In 15 minutes. So what is the speed of boat through shortest path? It is equal to distance upon time. Distance is 1 kilometer and time is how much? 15 minutes means 1 by 4 hour. You know, it is 1 by 4 means it will be 4 kilometer per hour. It is clear? Means what is the speed here in this direction? 4 kilometer per hour. You have to find the speed of the river in kilometer per hour. So see here, he has to travel in this direction. Boat had to go along this direction. Now in order to go in this direction, boat will keep his motion along this direction. Boat will keep his motion along this direction. It is clear? So that under the flow of river current, it can come across this. So this is the actual direction of boat in which the boat is sailing. With what speed? With the speed of 5 kilometer per hour. What is the speed of river? It is this VR. So you can see here, you have to calculate the value of VR, speed of the river in kilometer per hour. So in this triangle, you see the triangle, this is a right angle triangle. In right angle triangle, 5 square equals to VR square plus 4 square. 5 square equals to VR square plus 4 square. So when you will simplify, it will come out what? It will come out 3 kilometer per hour. Means what is the speed of the river? It is 3 kilometer per hour. It's clear? Now see the next question. Now here a man is moving. Now this is the rain problems. It's clear? Man is moving with a speed of 4 kilometer per hour towards north, and the rain is falling at a speed of 6 kilometer per hour in the vertically downward direction. Man is going with this speed in what direction? In north. And rain is falling vertically down in this direction. To protect himself from the rain, in which direction should he tilt his umbrella? You have to find this. So see here, you take this direction as the north direction. This is the south. And this is the vertically downward direction. Rain is falling in this direction with what speed? With the speed of 6 kilometer per hour. And man is moving in what direction? Man is moving, here you can see, 4 kilometer per hour towards north. Means this is the direction of motion of man. This is the 4. 4 means 4 kilometer per hour. Now in which direction should the man should keep his umbrella? So suppose the man is standing. If the man is standing, then in what way he will keep his umbrella? He will keep the umbrella in this way. Because the rain is falling vertically downward. Rain is falling vertically downward. It is falling vertically downward. So if the man is standing, then what will happen? He will keep the umbrella this way so that he is protected from the rain. He is protected from the rain. But here man is moving in this direction. With what speed? With the speed of 4 kilometer per hour. So now in order to protect himself from the rain, he will keep the umbrella in what direction? He will keep the umbrella in order to protect himself from rain. He keeps umbrella in relative direction of rain with respect to man. Means what you have to find? You have to find VRM, relative direction of rain with respect to man. How will you find? in the velocity vector of rain, you will add the negative velocity vector of man. This is the rule. So how will you add the negative velocity vector? Vector Vm is in this direction. So what will be the negative vector Vm? Negative vector Vm will be this. What will be the resultant of negative vector Vm and vector Vr? That will be this. This will be, by completing the parallelogram, you can find. This will be the direction of VRM. It's clear? Means the rod of umbrella should be in this direction. Rod of umbrella should be in this direction. When rod of umbrella will be in this direction, what will be the umbrella? Umbrella will be this. So you have to find by how much angle from the vertical he tilt the umbrella. This theta you have to find. Now this is theta, therefore this angle is also theta. Now by using this triangle, you can see here, this is a right angle triangle. By using this triangle, you can find this theta. So see here, with respect to theta, this is given how much? This is the magnitude of negative vector Vm, which is 4. What is the magnitude of this? It is Vr, so it is 6. So tan theta will be equal to, it is the magnitude of negative vector Vm divided by magnitude of vector Vr. That is equals to 4 upon 6, that is equals to 2 upon 3. So here he should tilt the umbrella in what direction? At an angle, you can see here, at an angle theta from vertical towards north. At an angle theta from vertical towards north. So see here, he should tilt umbrella by an angle theta from vertical towards north. It's clear. Where tan theta is how much? Tan theta equals to 2 upon 3. That you have to calculate it. It's clear. Now see here, if in the same question it is asked that what is the direction of the resultant direction, what is the direction of the rain, relative direction of rain. It's clear. So you can see here, now direction of rain, instead of falling in this direction, now it appears in this direction. It's clear. Instead of falling in, you can see here, instead of in this direction, now the direction which appears is this. Now the direction which appears is this. Now this is in what direction? It is at an angle theta from vertical towards south, this is towards south. It is clear. So direction of relative velocity is what? Of relative velocity. It is at an angle theta from vertical towards south. That is and here tan theta is already you have calculated 2 by 3. It is clear. So this you remember. He will keep the umbrella, he will tilt the umbrella towards the north, but the direction of, relative direction of rain will be towards south. Theta angle from vertical towards south. You can find its value. What will be value of VRM? So VRM will be very simple. In this right angle triangle, this is the right angle triangle. 6 square plus 4 square equals to VRM square. 6 square plus 4 square. So see here, 6 square is 36, 4 square is 16, that is equals to 52 perhaps. It's clear? 52. So VRM will be square root 52. So that you can find, that I am not doing here. VRM will be here how much? Square root 52 meter per second. So this is the question. Now there is one more question on the same. A man is moving on a horizontal road in east direction with a speed of 10 km per hour. If the rain drop is falling at a speed of 5 km per hour in vertical downward direction, what will be the magnitude of resultant velocity, means this thing, and its direction with respect to man. With respect to man, you have to find its direction. So this is very simple. See here, man is moving in what direction? In east direction. With what speed? 10. And what is the speed of falling of the rain? It is 5 km per hour vertically downward. So we can see here, we can solve here in this page. There may be some extra pages here. I am taking at the last. Or let me erase this. It's taking time, but yes. So see here, now you take this direction as east direction. So this will be what? West. Man is moving with 10 km per hour and rain is falling vertically with 5 km per hour. Means what is VR? It is equal to 5 km per hour. And man is going with 10 km per hour. Means what is the VM here? VM equals to 10. So here you have to find the relative direction of rain with respect to man. What will be the magnitude of the velocity of the rain and its direction with respect to man? So see here, direction of rain with respect to man, rain with respect to man, it will be relative direction of rain with respect to man. Means here you have to find what? You have to find velocity vector VRM. And already I have told that what is VRM. So VRM is what? It is the vector sum of vector VR and negative vector VM. Vector VR and negative vector VM. So see here, what is the negative vector VM? Negative vector VM will be this. This will be the negative vector VM. What is the resultant of these two? You can complete the parallelogram. This will be the VRM. It's clear. Now you have to find this direction. You have to find what will be the magnitude of resultant velocity of the rain means you have to find VRM, its magnitude, its value, and its direction from here. It's clear. So very simple. Magnitude you can find. This is how much? 5. What will be the value of this? Its value will be equal to magnitude of vector Vm, which is given 10. Which is given 10. It's clear. So what will be VRM? So if you see here, I am doing here only. VRM will be in this right angle triangle. This is the right angle triangle. You can see here. VRM square equals to 5 square plus 10 square. 5 square plus 10 square. So it will be equal to 125. 125, so it will be something 11, because 11 square is 121, so 11 point something. That you can calculate. This will be the resultant velocity. Magnitude of resultant velocity 11 point something meter per second. Now you have to find this angle theta. So what will be tan theta? Tan theta will be equal to magnitude of this, which is the magnitude of negative vector Vm, upon magnitude of Vr. Magnitude of Vr, that is equals to 10 upon 5, that is equals to 2. So tan theta equals to 2, so theta comes out here approximately 66 point some degree. Theta is, you can check from the calculator, it is nearly 66 degree. So what will be the direction of rain with respect to man? Theta plus 90. Theta plus 90. It is clear. So direction of rain with respect to man, it will be 90 plus theta. It's clear. So you will get some more similar questions. Question 11, 12, 13 on page 203. It is 203, but these are the different questions. Page 203 of some other book. It's clear. Now, the remaining question of this I will do in the next video.